Hi everybody, this is Gigi from Kauai Community College. In this video, you will be working with Venn diagram. Let's get started.
All right, Venn diagram. Before we get into Venn diagram, we want to define what a set is, okay? A set is a collection of objects, living or non-living, and members of a set are those specific objects within it. For example, the members of the set of days of the week are listed below. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So those are the members of the set. And this set is called set of days of the week. And we usually use this bracket right here to denote a set. Okay. Now, Venn diagram. You've seen them before, I'm sure. Is a visual way of describing relationships among sets. For example, we have set 1, which would be a set of whales, and set 2 is a set of fish, right? So we know that whales have hair and they give life birth. They breathe air. Okay. And fish, we know that they lay eggs, have scales, and they breathe in water. Now, they do both live in water, have fins, and can swim. So this middle part right there is the common element of A and B, two sets, whales and fish, right? Okay, now let's start working with Venn diagram. So suppose you have set A defined as multiples of 2 from 1 to 20. And set B are multiples of 3 from 1 to 20. Okay, so let's visualize those sets. Okay, so set A would be 2, 4, 6, 8, and so on, all the way up to 20. Okay, set B would be multiples of 3, and that would be 3, 6, 9, 12, 15, and 18. Okay, so pause the video right here, draw the Venn diagram, and put the members of these sets where they belong in your Venn diagram. All right, so when you come back, let's check your answer. Let's do a Venn diagram here, A and B. Okay, so starting with set A, I say on the left, B on the right, and the middle part would be members of both A and B. Okay, so 2 would be just belong to A, but not B. 4 belong to A, but not B. 6 belong to both A and B, so it goes in the middle. 8, 10 are only in A, but not in B. 12, however, is in both A and B. And then 14, 16 only belong to A, but not B. 18 belong to both A and B, so it goes in the middle. And then number 20 only belong to A. Okay, now I'm gonna go over to set B and deal with those members. 3 belong to B, but not A. 6, as we saw, belong to both A and B, so that goes in the middle. 9 is in B, but not A. 12 belong to both A and B, so that was in the middle. And then 15 is in B, but not A. And that is it. So a Venn diagram, again, is just a way of describing the relationship between ZA and ZB. Okay, let's try another one. So you probably see examples like this one. There are 30 children in a class. They all have at least a cat or a dog at home. Okay, we know when we ask, how many of you have a cat? 14 kids said they have a cat. 19 kids said they have a dog. How many children have both a cat and a dog? Okay, so pause, create a Venn diagram, and think about it. All right, here we go. Now, how do we know that the middle part, okay, we know that there are 30 children, right? How do we know that the middle part, the part that own both cat and dog, is not empty? Meaning there are some members in there. Well, we know that because 14 and 19 is more than a total of 30, right? So some of them have to have owned both a cat and a dog, right? That's the logic there. So when we take a look at this, we would say the total, which is 30, is going to equal to the cat circle plus the dog circle. But when you do that, you would have counted this part right here twice, the overlapping part, right? So we have to subtract out that part. Okay, so that would be the total would be 14 plus 19 minus the overlapping part that we have counted twice. Okay, do some math here. 14 plus 19 is 33 minus the overlapping part here. Okay, and when you solve for that overlapping part, the part where the kids would own both a cat and a dog, you would get 3. 33 minus 30 is 3, right? Or 30 minus 3 is 30. So we know that there are 3 children who own a cat and a dog, which means how many of them really, I mean, I already answered the question here of how many have both a cat and a dog. That would be 3, right? But to really explain further, how many actually just own a cat? Like cat only. So cat only would be 11 because the total of 14 kids that have a cat, 3 of them also own a dog. So 11 of them owns only a cat, right? How many then only have a dog but not cat? That would be 16 because 19 minus 3 is 16. Now, if you add these numbers together, we do have a total of 30. Awesome. And that's how Venn diagram works, right? Now, imagine that you have 2 sets, right? And that would mean 2 circles. How many different possibilities can you draw the Venn diagram? Meaning, like, what are the scenarios? Okay, pause and doodle. 2 circles, how can you draw them? How many different scenarios do you have? Okay, now that you come back, let's see what you've got. You could have this, which is what we've seen before, and we call that overlapping. In this scenario, we would say some members of B belongs to A. Some members of B belong to A, or some members of A belong to B, right? Some, not all, but some members of B are in A, okay? Or some members of A are in B. Okay, that's one scenario. Did you get that one? Great. Okay, what other scenario that's different than this one? How about that? Did you draw that? That is what we call disjoint sets. A and B are disjoint. That means no members of B are in A, or no member of A are in B. There's no common element. Okay. Is there another scenario? Did you draw another one? Of course you did. It would be something like this, and we call this scenario a subset. B is a subset of A. So how do we describe this? We would describe this as all members of B are in A, right? So pay attention to the quantifier. Some, none, or all. Okay, that is it for today. Remember this screen. Okay, get this in your brain, because what we're gonna do next is we're gonna use Venn diagram to evaluate arguments in logic.